Good day to you, my dear friends. Oh, it's time to sell. It's time to sell. No, it's time to solve some LeetCode problems. Well, you know the drill. First of all, we go back to some previously solved problems. The problem is that yesterday we solved a lot of problems and I wasn't able to investigate, to research each and every one of them. So we're gonna talk about two problems. Two easy problems that we got randomly from Leet rooms yesterday. It's goal parser, interpretation and longest palindrome. Also, there were two medium problems that I failed to solve from Leet rooms again. And one of those problems it was brainless society. One of those problems, minimum area rectangle, I want to continue today because this problem it occupied my brain. I wasn't able to sleep today. I was thinking again and again about this problem and maybe I have a solution. I'm not sure, but we're gonna try. So I could sleep again, you know. It's a disaster. But first things first. Goal parser interpretation problem from yesterday. Let's clear everything. So this is a simple problem because we have this string and we want to turn it into that string, for example, using this dictionary. And we solved it yesterday using gsub twice. So we can replace two brackets with O, I said, and again gsub, and this monstrosity we're gonna replace with, well, the same thing but without brackets. Like this, right? And even yesterday I asked a question that probably we can do this with just one gsub, and yes, of course it is possible. How is it done? Well, first of all we need to create a regular expression, and for that I usually use rubular. So as a test string, let's use this goal. And how can we choose this combination? Two brackets. If we just type two brackets, it's not gonna work because brackets are some kind of a special symbol that we use in when we construct regular expressions. So we need to use something like this. And you see, we were able to choose brackets. Now we want to choose also this part. So let's do this OR operator. And now again we're gonna use two brackets and L in between. You see, it works. Let's take it back to our gsub, and as a first argument we're gonna use a regular expression, and as a second argument we need to use a dictionary, a hash. So we want to say that we want to translate two brackets as O, and we want to translate two brackets and L as L, something like this. And probably I forgot something, but let's check. Yeah, we have an extra brackets as usual. Not brackets, how do we call it? I forgot. Yeah, it's green. So it is possible to do in just one G-sub. But for training, let's also do it without G-sub, you know? Let's iterate through this string. And we have similar solutions here in solutions section, but, like this. But they are very long. They use too many variables, they use too many conditions. I'm not sure that we want to do that. Let's create our own shorter version just to practice. So of course, you see, this is the condition, his condition or her condition, I don't know. We're gonna use a much simpler condition. Let's start with index 0, and while command index, we're gonna do our loop. And if command index, I'm not gonna check if it's G, I'm gonna check if it's an opening bracket, because we have this opening bracket here and also here. Let's use it. So, opening bracket. And if it's not an opening bracket, then it must be G or any other letter. Well, in this case we just increment our index, of course. Here we have two situations. Let's check if command index plus 1 equals closing bracket, then we have this thing. What do we want to do in such a terrible situation? Well, first of all, we want to replace command index with just an O, and we want to get rid of this command index plus 1. We do not need it anymore, so let's replace it with empty string. And of course we increment our index by 1. But let's check this situation. What do we want to do here? Well, we want to get rid of, let's say we are here, index plus 1, plus 2, plus 3, I think. I'm not sure, but let's check. We want to get rid of this, and we want to get rid of this, the opening bracket. And we want to do this in that order, because if we remove this character first, then we're gonna need to use index plus 2 and not index plus 3, right? So it's a little harder for my taste. But let's do this the hard way, you know. And now we're gonna have L we're gonna have two symbols. No, can't increase. Hello. So we're gonna increment by 2. You see? And I think it's gonna work. Yes, it's green. Now, of course, we can do this index +1 in the end, and then we do not need to do it here, and only add 1 here. Easy. That's right. No, of course I broke something. Oh yeah, I need to end this. It's not hard, but I try to solve problems using different approaches. Just for the training purposes. Great. Now the second problem from yesterday was, let me see, longest palindrome, and it's a funny one. Well, my solution, if you remember it at all, well, it's legit, it's good. Oh no, don't look at this. Don't look at this yet. Smart coder, hello. I think this was my solution from yesterday. Let's go back to it. And here in solutions sections, there are many similar solutions. Well, some are shorter by a few lines, some are longer, but among these solutions, there is a craziest thing called bit magic. Well, it can be done as a one-liner, or it can be done as like in 3 lines, but look at this bit magic. Now, it's hard for me to understand what is going on, but notice one thing, that we wait, it's not my final solution. Maybe this one, maybe even this one. Yeah, let's take it. We added this variable just to track if we already had an odd number, you know, and we did this check in the end. But in this crazy bit magic solution, where is it? He doesn't do that. He doesn't have this variable. So how does he check if he already had an odd value? And it's hard for me to understand how it is done using bits, but it gave me an idea. So let's say we sum even numbers, and you're definitely gonna get an even number as a result, right? Imagine that we have this first odd number. So we have even numbers plus this odd number, first odd number. We're definitely gonna get an odd number as a result. And if it's not a first, I can't even type today. If it's not a first odd number, if it's the second one, we're gonna get even again. So we can remove this. We do not need it anymore. So if value is even, we just add this value. Else let's say if counter is even and our value is odd, then we want to do this. Otherwise, we want to do this, right? Am I right? Let's check. Beautiful. Well, notice that we do the same thing everywhere. So let's just counter plus equal value every time. So is it gonna work? Yeah, seem much shorter. And of course we can continue. So let's rewrite it so I could see better. So it's counter -1 So counter is gonna equal, depending on this condition, it's not gonna be counter, it's gonna be counter plus value here. If this is the case, we're gonna return counter plus value -1. Otherwise, we're gonna return just what? Is this your solution? You about this part? Wait a second. I can make a default, but I can do even better. The thing is, and again, the solution from this guy helped me realize that we have a very nice tally method in Ruby. What does it do? Well, basically that. He counts everything in the array, how many times something repeats in the array, and it creates a hash. So we're gonna do just tally and let's put it here, and we do not need hash anymore. You see? And let's use reduce instead of each. It's gonna be our counter. So it's gonna be our counter, and here we're gonna have value. And here we're gonna put the same thing. And I think it's gonna work. And we do not need anything anymore. And it's an ugly motherfucker, right? So brainless society should be happy with this one-liner. It's ugly as hell. Why reduce and not just sum? Well, yeah, I guess we can sum. Let's try it. And just sum, and then we need just this value. Wait. So, nah, I don't think we can sum. Because we use the result of previous sum, you know, in this check. Oh, fair enough. We have this condition, we check the result of a previous sum, and I don't think we have an access to it when we use sum method, because only in reduce we have this accumulator that we want to check on every step. And now, finally, I want to go back to the medium problem from yesterday that killed me. Oh, it was bad. It was minimum area rectangle. And I already told in the beginning of my stream that I just couldn't sleep today. I was thinking again and again and again about this problem. We do not need all of this. So what I did here is I created a hash, of course, as I always do. And in this hash we have for every y, like for y3, all the points in this horizontal line. At the very least, I hope so. Let's check this out, because I don't remember what happened here yesterday. I want to solve this problem so I could sleep again. What? Oh, of course it's not. It's hash values. And I even understood that we do not have to store these ones or threes, because this information is stored in the key already. So why should we duplicate it? gonna just put 0.0 in our hash. Let's check it out. Much better. Now let's draw, believe it or not. So I have now all these horizontal lines stored, but I do not know in what order they are stored, so I want to sort them, that's for sure. Hash keys sort. Okay. So now we know. Now we know. What do we know? In this example, we know that we have 3 horizontal lines at y's 1, 2, and 3. So we have 1, 2, and 3. And we definitely have points somewhere on this line, somewhere on this line, and somewhere on this line. Now, remember that we want to find the smallest rectangle. So we want to start probably with the closest lines. The closest lines. In our first example, in our first test case, there is a similar gap, just one, but it can be different. It can be a lot of lines. So, how are we going to solve this problem? Let's create an array of pairs. And we're gonna iterate through our sorted keys and if we have sorted keys I plus 1, we're gonna put in our pairs an array of key and sorted keys I plus 1. Now in this pairs we're gonna have, well, pairs of lines. One and two and 3 for now. Of course, it's not a final solution, because what if there is no rectangle in these lines that go one after another? Maybe we need a bigger gap, maybe, but we're gonna check this later. Well, let's say our min rect equals 0, and while min rect equals 0, and we need another condition, of course. wrong? It's very strange. Very strange indentation. So like this. No, like this. Yeah, now it's good. So we have this while loop. And we're gonna have this, not gap, what is offset? Let's call it offset. And offset is exactly what we're gonna use here. When we do I plus 1, it's not gonna be 1, it's gonna be offset. And in the end, of course, we're gonna increase our offset. But what is our limit here? Well, imagine that we have a lot of possible lines, and there is no rectangle anywhere. So the last hope is, you know, the first line and the very last line. And it's just a length of sorted keys length, I think. Maybe -1. Yeah, because say here we have some index and we want to add n-1, of course, otherwise we will be here somewhere. So we're gonna do this while offset is less or equal the length. Let's just run it. Probably it's gonna break. Time limit exceeded. Well, that's what I was afraid of. Time limit. Okay. Wait. Even in the first test case, time limit exceeded. We need end here, right? Yeah. Much better. So we have all these pairs. And we want, unfortunately, to sort them again. We want to sort them by the difference between two elements of the pair, but of course we want to take an absolute value. Why do we do that? Because we want to start with two lines with the minimum difference, because we are looking for a minimum rectangle. I forgot the word. Rectangle. Yeah. So we're gonna start from the smallest distance between two lines. Now we're gonna iterate through these pairs. What do we have? No, not that. It's time to use our hash. So hash pair 0 and hash pair 1. I think we want to find an intersection between these two arrays, because each of them contains points on a line. But only an x coordinate. So they're gonna intersect. That's why we didn't store the y coordinate. The y coordinate is stored in a key, not in a value, so it won't break everything for us. The only problem is I do not remember intersect method in Ruby. Intersection. If it's gonna work at all, because it's a new method. Oh, it's easy enough. Intersection. Oh, I'm so hungry. I'm so hungry. So this is our intersection, and in this intersection we want to find it's too hard to read. Let's call it something. Intersection. Intersect is this thing. We have an array and we want to find a minimum difference between two elements of that array. It's gonna be easier if we sort it. It's another sort. We're gonna hit a time limit for sure. Let's do difference is 0. Now let's iterate. Intersect each with index, unfortunately. do. Let's call it x because it's an x coordinate, and let's call it x index. Oh my god, thank you very much. I'm kinda in the middle of something here. It's very hard to explain what I'm doing. But a short summary for you, Yesterday, during solving some random lit rooms problems, I encountered this one medium problem and I wasn't able to solve it, but I also wasn't able to sleep afterwards. I kept thinking about this problem again and again and again. It was terrible. So now I am possessed. I need to solve it no matter what. I want to sleep too much. Well, so I had a lot of time. Yeah, and I think I invented a solution. The only problem is time limit, of course. It's not a Chad mentality, it's more that I didn't have a choice in that matter at all. I just wasn't able to sleep. Sometimes your brain gets so occupied with some question that you just can't empty your brain and go to sleep. You just can't put it on pause. Oh yeah. Oh, thank you very much. Thank you very much. It's almost a month of my everyday streaming. I think I started at, what was it, 26th of June, and now it's 24th, so I think I'm gonna celebrate somehow to do a longer stream or something. But let's continue with this. It's such an awful problem. Oh, everybody loves Ruby. Well, no, that's not the truth. Nobody loves Ruby. So, if x index is more than 0, we're gonna compare x minus intersect index minus 1 index minus 1 is bigger than diff, we're gonna do this. So this difference is the minimum difference between 2 points in one line, in one horizontal line. And and in pair 1, let's call it diff x. So this is our diff x, but we also want diff y, of course, and it's gonna be the difference between pair 1 minus pair 0. and they're sorted as far as I remember, so we do not need to add a module to add an absolute. And yeah, our min rect is gonna be diff x by diff y, and it can be 0 still if we do not have anything in intersect. Then we're gonna have 0 and we're gonna continue with our while loop. But if we already have this min, if min rect isn't 0, we're gonna break, I think. Oh, he missed a great one-liner today from me. It was deliciously ugly. I do enjoy one-liners too. But, well, good luck with making a one-liner out of this. So, if doesn't equal 0, we're gonna break from this loop because we already found our minimum rectangle. So we do not go through this path anymore. Okay, let's check what's gonna happen. Index. Oh, of course, it's not index. It's not index. It's x index. X index. Like this. Let's check again. Code red. Null. Well, of course, it's because we do not return anything in the end. No big surprise here. At least the first one is green. What's wrong with this one? We count 4, but it's 2. But why? Let me think. It's a second case, this one. Have this min rect. Oh yeah. We're gonna do this only if min rect is even smaller. No, if this is even smaller than min rect that we already have. No. Then we're never gonna get rid of 0. Yeah. Well, or right? Come on. Yeah, I stream at a very unfortunate time, but you know, for me it's a morning, and before the stream I like to have a morning run, so I can't stream earlier because of this morning run. Well, yes, if only I wasn't running, because it's impossible to run later here because of the weather. It's too hot. It's like more than 30 degrees Celsius. I don't know what is it in Fahrenheit. but it's hot. Only in the early morning you can run here. So all these, they were on one line. Why did we choose this distance and not this distance? Because you know I sorted by distance. Where was it? Here. I so want to solve this ugly problem. Oof, it doesn't look like a calculus problem, I don't know. I think it's just a common sense problem, to tell you the truth. Oh, because of this condition it happened. Don't want to break here. No. Oh, what does it mean even? Let's do it like this. No. Still 4. Why is it 4? How can we debug this ugly monstrosity? It's so huge. Oh, this is a problem. This is a problem. But we need additional condition. If we already found minimum. Oh, come on. And let's solve a problem at hand. We have a wrong result somehow. Let's see what we have in our hash. In the second case. 1 3 4 and 1 3 4 makes sense. Yeah. And sorted key is gonna be 1 and 3, right? One, 2 and 3. Why is that? Well, I was stuck yesterday because I didn't even have an idea how to proceed. Now I'm not stuck, I just have to debug this thing. But I think the logic is sound, so I guess it's possible to solve it like this. I just need to find the mistake. So sorted keys, hash keys, sort. And we got 1, 2 and 3. Oh. Yeah. I look at different test case. 1 and 3, good. Still good. And what? Let's check an offset. It should be 2 in the end, I guess. Yeah, offset 2. What else? What is length? Let's check everything. And what do we want length to be? It must be 2. No, it must be 1. Length is 1. Yes. So we do just one loop, because then offset becomes bigger than length. Just one loop, and that's right. Then we do this with sorted keys. We create pairs. Can we look at our pairs? Or they are hidden somewhere? No, they are at top level. They are visible for us. Let's check our pairs. And that's gonna be just 1 3 1 2 2 3 1 3. Oh, it's the wrong test case. Come on. Yes, now it's good. It's 1 3. Because we only have 2 lines here. It's 1 and 3. Great. Then we sort pairs by. Oh, let's check this, by the way. Oops. No, it's gonna be the same because we only have 1 pair. Not much of a sorting, you know. Then we iterate. Aha. We can do this, by the way. Let's check what we get here. It's not pair, it's gonna be pairs 0 0. Here pairs 0 1. 1, 3 and 4. So these are values of x, 1, 3 and 4, that are presented on both lines. That's great. 1, 3 and 4, we have it. And diff x is 0. And we go through intersect to find the minimum distance. So the problem must be here somewhere. It's gonna be smaller because we looked for a smallest difference, not the biggest difference. Bloody hell. Let's check min rect. Let's return it. Go, go, go. We broke everything. Okay. So we go through this intersect, which is 1, 3 and 4. We skip the first index. We are at 3. So 3 minus 1 is 2. It can't be 0. It should be nil, probably. If diff x, such a strange name. I immediately remember the early 2000s where there was a div x codec or something like this. Do you remember? If div x, if no div x, or come on. That's unfortunate. Well, of course, we're gonna need div x for this. We're gonna hit time limit. We need another condition for while, you see? Because we need to stop if we know for sure that yes, we need this condition, then min rect doesn't equal 0, but also min rect must be smaller than offset. No. Bigger or equal than offset. No. Because at some point you should stop, you know, because maybe you have some rectangle here, but from some point what can be a minimum area? It's like 1 and offset. So just offset. And if our offset is bigger than our minimum rectangle, then there is no need to continue. Yes, so we're gonna have offset okay, and offset is bigger or equal than min rect. We desperately need this condition, because why do we go for these huge rectangles and huge numbers when we already have our minimum? No, smaller. But offset is not gonna be smaller if min rect is 0 at the beginning. That's the problem. And min rect doesn't equal 0. But if it doesn't equal 0, that we're not even gonna start this loop, because it equals to 0 in the beginning. So we're gonna have an OR here, or min rect equals 0. Please work. At least these two cases. Great. Now too long, still too long. Oh yeah. With this amount of sorting, it's bound to happen. It's a long bastard. Look at this. Oof. It's huge. How many points do we have here? Let me check. Curious. Oh. Oh no, I broke everything. Wow. Yeah, it's a huge array. It's too long. I can't even paste it. Oh god. Let's just take this ugliness and count it here. Just to see how ugly it really is. Oof. So what can we do? Probably we want to break here if maybe it can help us a little. Ooh. How come? No, with trees you can usually see a tree. It would be so nice to be able to see this thing. No, our pairs are sorted. Oh, no, no, no. No, no, no. I'm gonna break if we have diff x and diff y. If we have them both, then we have a new min rect here, and then we want to break. Nah, that's a problem. We want to break here on some condition. It's like we want to compare an old value of min rect and the new one. So when we go into this loop, we want to save old rect is min rect, and we want to break if min rect doesn't equal old rect anymore. In this case, we want to stop iterate through these pairs, because all the other pairs are even bigger. The difference between elements of these pairs are bigger. Let's check. Be green. Green. Oh, and this case was green too. No, the same. 87. What else can we do? Where do we waste too much time? Well, we sort like a million times. guess for 3 years maybe, but I wasn't learning it. I was learning it for like 3 months, and then I started working, and then there was more work than learning. Of course, I still continued to learn JavaScript in the evenings and started to solve LeetCode problems, but of course, for the most part, I was working, and when you work, you do not have that much time for studying. But still, I try to study at least an hour a day. It was like my principle. So I have 3 years of experience, but it's not. Well, when you work, you do similar tasks. So sometimes there is not much learning opportunity, especially in terms of theory. You do not get theoretical knowledge, and that's a huge gap for me. I don't know if that answers your question. Well, still I try to do some learning every day, you know, just half an hour maybe. Otherwise, when you decide to change your job, you will find out that you lag behind in so many areas. Like nowadays, everyone uses AWS, for example, and if you don't use it at your work, well, then you are fucked basically. You have to study it in your spare time to keep yourself up to date with modern technologies and so on. And that's a huge problem. You work and you even considered a middle in your company, but in other company you may know nothing at all, and that's a problem for me. I don't know where is the problem. So I think I'm gonna have another sleepless night ahead of me, because I need to invent a way of simplifying this. But we need to solve something today, that's for sure. So let's find some other problem maybe. Just to solve something today. What is easy? Count nodes equal to average of sub-tree. Well, yeah, that's a problem. But you know, I still buy paper books and I take them with me on travels. I mean books on programming. The only problem is they are expensive as hell. But that's an option. So, given the root of a binary tree, return the number of nodes where the value of the node is equal to the average of the values in its subtree. Interesting. What if it doesn't have a subtree? I see. What do we want to return if there is no root? Let's say 0. No, not 0. Well, let it be 0 for now. It's a funny problem. So in the end, what do we want to return? Oh, I think this problem is too hard in my current state. Well, we want to return sum divided by count, let's say. That's what we want to return. But what is sum? Sum is the sum of all the subnodes. So it's like we want to return this array of sum and count. Let's have an array. No, let's not have an array. Why not? Let's have an array. No. This one is strange. Let's see another example. So we always consider the node itself. So for every node, sum is equal to try to do this. Left. For now, let's do it like this. Node value plus the same for the right. But we return this. So if we want What do we want to return? Like 0, 0, and 0? Well, because we have 0 elements, zero value, you may say, and we have a 0. Let's call it result equal 0. So we're gonna return result, I guess, if no root. Here we want to use 0. That's crazy. And count gonna equal to what? One plus 1 plus this. I'm so not sure about this one. It's our count. And of course we want to check if sum divided by count is equal to root value, and if then we want to plus 1 our result, and we return this. But we want to return this only if result doesn't equal 0. So result doesn't equal 0, we return this. Otherwise, we return result. I don't know. Ugly. Yeah. 0, 5. Oh, whoa. Of course, we want to send result here. Otherwise, it won't work. Oh. Nope. So, let's imagine we are here at the beginning. We check if we have a root, and we do have a root, so we're gonna count time. No, let's imagine that we are here. Oh, this is a problem. We do not return. So we are here. We do not have a left node, so we return 0, 0 result. So we return 0 here for sum, but we have root value and it's 0. And here we have 0 also. So sum equals 0. Let me write this down. From one hard problem to another. What's going on with our count? Well, we do not have a root, so it's gonna be 1. Count is 1. Now we count average. I think I see my problem. Oh, let's leave it here for now. This is my problem. It looks like we need another very stupid variable first node. It's gonna be true. And here we're gonna send false everywhere, of course. Oh, it's so ugly. And I forgot about result here, so many mistakes. Maybe we do not need false after all. Result and false. So if first node, we're gonna return result. Otherwise, we're gonna return this array. Better? Well, of course, it's just 1. It's 1. Well, now let's count. Oh yeah, we need not this result. How is it done? Is it sum, count, and result? Nah, it can't be done like this. See, we return result here, but we do not use it. What if result is an array? What if it's an array? So it's modified everywhere. Ugly. $15. Nice. Come on. Let's see what's going on again. So we are here. We divide 0 by 1 and we get 0, of course. And 0 is equal to 0. So we want to update our result. Result 0 is now equal to 1. We do this twice. We want to do this only once. Let's do something like sum left and count left. I don't remember if this can be done. Then we can use 0 again. I guess. So sum gonna be equal sum left, of course. Here we're gonna have count left instead of this. But we want to do the same thing for right. Something like this is possible in JavaScript, but I don't remember if we can do this in Ruby. I just don't remember. It's such a long stream. Jesus. Root right. Result false. Okay. Here we're gonna have some right. Here we're gonna have count left and count right. And here we're gonna have result definitely gonna be equal to result left plus result right, but also this, of course. Oh, interesting. A minimum area problem. Well, I'm gonna return to it tomorrow. Another day, another attempt. Oh, you can't do like this. How is it done? I don't remember. How do we reconstruct? Not reconstruct. What is the word? Well, same for me. Same for me. Exactly the same. It was like case number 89 that broke everything for me. And I counted elements in this test case, and it was like 497, 95 elements. And yeah, that's too much for my idea. So back to the lab. I don't remember syntaxes. Let's check this out. Ruby turning array into variables. Oh yeah, just like this. Nice. So this should work without brackets. Yeah. Thank you, thank you. It's all green. Please, I want to finish for today. Please work. Oh. Yeah, it's not a one-liner yet. Maybe tomorrow we're gonna be able to turn this into something truly ugly, as we love to do. But that's gonna happen tomorrow. So thank you, Brainless Society, for always being here despite your need for sleep. Appreciate that. Ooh, it's time for us to go. Thank you all. I'll see you tomorrow. I won. Adrian. Yeah, I understand your feelings.